Well, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik. It's great to have a lot of comet hunters out here in the audience, and so I'm glad you were able to make it up here today. Did everyone get a chance to see the comet yet? Nope. A couple people know. All right. Well, it's certainly hard to see it. But it's out there, and I know we're going to be having some other people come in. The observatory lobby is still pretty full of people, but we wanted to get this started because we've got a lot to cover today, and there's a lot to see tonight. So anyway, just show of hands, who's here for the first time or hasn't been here since your 4th grade field trip? All right, a few people. All right. How about who here are members? Oh, okay, great. A good number of people. Well, especially for the people who just say they're here for the first time, people that raise their hands second actually have a valuable piece of information, and it's how valuable the Kopernik membership is. We are a nonprofit organization. We are not funded by any university or government entity, so we depend on the programs that we offer, both to schools. We do fairly extensive summer camps, but our membership is connected to an organization called the ASTC, Association of Science and Technology Centers. And basically, we all share each other's memberships. So a Kopernik membership, like a family membership, is $75 for the year, gets you into any Friday night program here, but also gets you into over 380 other science centers. So you could go to Robeson for free. You could go to the Museum of Science and Technology up in Syracuse for free, or the Franklin Institute down in Philly, or even the Intrepid Museum down in New York City. So if you like this kind of place and want to support us, consider getting a Kopernik membership. All the programs we offer here are, at least on Friday nights, we also offer on our live stream, and we like to welcome those watching on the live stream. And we actually do have people watching from literally around the world. And good morning, Lindsay in Adelaide, Australia. She comes in every Friday night. For her, it's Saturday morning, and from Adelaide, Australia, to watch. So let's all say hi to Lindsay. Hi. All right, very good. All right. Anyway, but now we have over 13,000 subscribers. We're actually closing in on 14,000 subscribers on our YouTube channel. And what's great about this is, again, we do this live. So if you're unable to come up here on a Friday night, just go to our YouTube channel and you get to watch it live. You can actually then ask questions through the chat. Anyway, we got a lot to cover tonight, and I think I'm going to push this right into our live stream astronomer, Jenny Cartie. Jenny actually is responsible for, I'd say, 12,500 of the 13,000 subscribers. Jenny does a fantastic job with her live streams. We do a number of observing live streams. We've done both lunar and solar eclipses. We've done some reaction live streams when the local astronaut Doug Hurley and Bob Behnken were the first astronauts to launch on a SpaceX Falcon 9 rocket. We watched that. We sort of had a watch party through our YouTube channel, and people could communicate through the chat. And then when they returned, we did the same thing. Watching them come down. So our YouTube channel is great, and what's also great about it is that it stays there. So if you want to see this program again, or if you want to go and take a look at any of the other programs that we've offered, go to our YouTube channel, and they're all up there. But so I'm going to press this right on to Jenny. So Jenny, take it over.
All right. Thanks much, Drew. Hello, everyone. Yes, awesome to have a full house tonight for the Comet. One thing I do want to say, since Friday nights are it's a regular observing night, that's when we're often open. And we're not scheduled for another comet observation coming up. It will be visible in the sky for the next couple of days, which we'll see. And even better through telescopes. So what I'm trying to say here is, if you haven't had the chance to look through our telescopes at the comet, try and do that tonight. Even if it means leaving the presentation early or something, I won't feel bad. because this is going to cover a lot about comets and meteors. We structure our presentations for about an hour. And last night, the comet did disappear under the tree line around 9 p.m. We should have a little bit more time with it tonight because it climbed higher in the sky. But just worth noting. The line, just with the lines and everything, I understand. So make sure you get the chance to look. Another thing I'll mention right away, and we'll see this in the presentation, try taking a picture with your phone, even over the next few days. You'll be surprised what it can do. Okay, so let's jump into this, though. Comets and meteors. And you see some in our portholes there into the universe. You see some different objects in the sky. And by the end of this, I hope you'll know how to identify them. Now, one you can only identify with the help of spacecraft. That one that you're seeing in the center there is from a ESA spacecraft, Rosetta, I believe. So you won't be able to get up close and personal with objects like these. Probably for the best. The dinosaurs know a thing or two about that. So we'll dive into trying to identify these different objects. Okay, I gotta remember I have my clicker here. All right, so this is what's top of mind for everyone, right? This comet. And I do have my pronunciation guide here. I tried to memorize it. I still need assistance. So it's Tsuchinshan is how you say the first one, and then Atlas. And then there's that designator before it. There's a lot going on in this name. And when we've done comet talks in the past, and there's a recent comet that we want to discuss, we like to break it down into what we're seeing here. So what do each of these things mean? Let's go through them. Oh, that didn't work. We get rid of them. Oh no. Hang on. Let me see if that slide's hidden. Oh no. Whoops. It got rid of all my animations. Oh no, it didn't. I'm just ahead of in my head here. Let's go back. We'll get to that designator. I just skipped a couple steps in the slides. All right. So before we get to breaking it down, I want to show you an image, probably our best image to this point at Kopernik, of the comet. And this is the same comet that's out tonight. This was taken on October 15th. It was through a mirrorless camera and a telephoto lens. And it was for the photographers out there, it was a 20-second exposure at ISO 3200. The settings will be similar, at least for the next couple days. You may have to bump up exposure levels a little bit. I will mention to you that this camera was also on a tracking mount, so that gave me the ability to get better pinpoint stars and track the comet a little better. You can see some of the waviness in the trees down in this area is coming from the tracking mount. Some of it's wind too, but it's catching up with the sky. So we're seeing a couple things here, a few features. We've got that very bright point in the comet that's called the nucleus. That's the actual solid body. Lots of light there, lots of reflectivity, high concentration of material around that as well. Then you have the tail stretching back. Can I use my laser pointer on this? Yes, I can. So you got the tail stretching. That's the dust tail. And then you have this other tail here. Those are rare. And if you've taken a picture of the comet tonight, you're probably not seeing that dust tail anymore. This was a few days ago. The comet was much brighter. Each day it's dimming more and more as it climbs higher in the sky and as it drifts out of our solar system. Or not out of it, further into it. So those are some of the features that you can see with comets. There is one thing missing from this image, which we'll talk about in some of our other comet pictures. So that's the best image we have because it was at that a brighter point on Tuesday. All right, going on here. This was the same night, much wider field in this image. So on the previous shot, I was using a 70 millimeter lens. This is a wide field image taken with a smartphone. Using, on Android, it's called, at least one version of it is called Night Sight, and then on iPhone, it's called Night Mode. And Night Sight in particular does a few minutes of data collection of the sky, and then it starts to decide what exposure was the best. In that time, it's stacking images. It's just trying to figure out the best settings. So it takes a while, takes a few minutes, but it's worth doing because it's going to give you the best image with the, frankly, the least effort, which isn't a bad thing. It makes astrophotography accessible. So I think that's powerful because it lets us see things in the sky that we otherwise can't as well. And an example of that here. Now, I will say this night, oh, we have a visitor. Okay, yeah, that's not too common to see in the sky, so you're seeing a very rare event right now. So the wasps are venturing inside, I guess, or the bugs. They came from outer space? Okay. Anyhow, the tail of this comet, on Tuesday, but also tonight, if you take some shots, you'll see it's exceptionally long. What was neat about Tuesday, and even before that as well, the comet was brighter the previous days. It was just cloudy here, of course. The tail of the comet was visibly long as well. You could see it stretching across the sky. Now tonight, you can just about see it jetting off the nucleus. And it's best to view these dimmer objects with averted vision, meaning you look to the side of the object and it'll pop more. So that was Tuesday night again. And now we can do a point of comparison using a phone. So again, something that's really accessible to everyone. On October 15th on the left-hand side, and tonight that I just took outside before coming in the building, same device, same exposure, because with night mode you can adjust exposure time. It'll try and default to the best situation, but you can also bump it up. So I bumped from 3 seconds to 10 seconds in this case for both shots. And you can see to a camera, to long exposures and wide field, it's not a major difference. I think we are getting some more tail detail on the left-hand side on October 15th. But otherwise, the shape of this comet is pretty similar, and the brighter part of the tail is also pretty similar. The only thing we've lost, if you look very carefully in the left-hand image, is that anti-tail shows up a little bit. So, again, this is something probably after tonight and tomorrow night, if the comet holds on to naked eye observing. This is what you would want to switch to after that. Visually observe, use binoculars, use a small scope, anything like that is great. But just to the naked eye, tonight and maybe tomorrow are probably the last opportunities. It's just about to skirt that line of losing it to the eye. Okay, so yeah, really powerful tool right in your pocket. Love pocket astrophotography. Make use of that. All right, now we're where I thought I was before. So now let's break down the name of this comet. You're gonna learn a little bit about how they categorize these things. in general, breaking this up into two parts. You have the C2023A3, and you have the Tsuchinshan-ATLAS. Those are two separate pieces. One is about categorizing the discovery timeline, and the other is about categorizing who observed it first. So let's click ahead here, and we'll see what each of those mean. On that timeline side, when it was discovered, first it designates C. What kind of comet is it? And in this case, the C category is for non-periodic, and that's greater than 200-year orbit. This comet has approximately an 80,000-year orbit. So it's exceptionally long. We won't see it again. This is not a regular period comet. The year of discovery was 2023, so just last year. And A3 is designating what part of the year it was discovered. So the A means the first half month of the year. So that means January, the first half of January. And then 3 means it's the third comet discovered within that first half month. So that's where all that comes from. And then you have the second section, and that's who discovered it. So the Tsuchinshan is actually translated into the Purple Mountain Observatory. So it's a place. It's a facility, and that is in the Jiangsu province in China. And then ATLAS, don't let this one scare you too much, but it's the Asteroid Terrestrial Impact Last Alert System in South Africa. They watch for these kinds of comets coming from what's called the Oort cloud. We'll see a depiction of the Oort cloud a little later. We know a lot of basically we know every short period comet, something like Comet Halley, that we'll see later at the 76-year period. We don't know about all the Oort cloud comets. And amongst all the near-Earth objects, like the asteroids that surround us, scientists carefully monitor those as well. And there's a really good map of what's out there near Earth. Oort cloud is really far away. Still part of our solar system, but super far out. And we can't track everything out that way. We often have to wait for it to start moving into the solar system. And that was the case for this one. You can see just from 2023 to 24, it made it into the inner solar system. Now it's on its way out on its long 80,000-year orbit. So ATLAS is a super important tool that's tracking and looking for these comet types. All right. So that's a breakdown of the name, where it all comes from. And the reason why there's 2 observatories is because they effectively it was detected in tandem, independently. So it's not like every center, every observatory has to comb through its data at a different time. So you may have collected data from one observatory and the other. They're not communicating, and discovery hasn't been put out there yet. So it was an independent observation, and so they put them together. Now, the other thing here is, what's a comet at all? And that's another thing we have to dive into now. So let's take a look at what I would say is our best comet image from here at Kopernik, taken by the Kopernik Astronomical Society. You've met some Kopernik Astronomical Society members tonight at the observatory. This is Comet Hale-Bopp from 1997. And it was a super bright comet visible to the naked eye I believe it was almost a -2 magnitude, which that's approaching brightness of Mercury, brighter planets like Venus and Jupiter. So very bright nucleus, and the dust tail would have been readily apparent as well. So major, major comet, and you can see, compared to our previous image, there was something missing from that compared to this. I guess we subtracted one thing and added another. Let's say it like that. We had an anti-tail in the other image. In this image, we have an ion tail. Those are the three types of tails that you can find when you're observing a comet from Earth. So let's see, bring the laser pointer back up. This is the ion tail. And you can see it's blue in color. And that's because it is ionized particles. Particles coming off of the comet being energized by the sun and actually glowing. We're not talking about reflectivity here. This matter coming off the comet is energized and glowing. It's illuminated. This material is the dust tail. And that is reflectivity. Same with the nucleus. That's all sunlight being reflected off the comet as well. And oftentimes, a major indicator for something being energized is it's going to take on this different color, a different color. And for ion tails, that is often blue. Now, sometimes you also might find a coma around the comet. You can classify the coma. You can't quite see the pinpoint nucleus here, but there is a coma surrounding this. Sometimes that coma can take on a green color. Again, for a similar reason, it's gases being energized by the sun and being illuminated. But otherwise, comets will often take on a brighter white color. All right, so let's go ahead. So looking at this once more, of our comet tonight, you see the anti-tail and you see the dust tail. You do not see the ion tail. And in this case, the anti-tail, it's often harder to see because of orientation required to spot it. Now, at one point, they believed anti-tails to be an optical artifact, an optical illusion effect taken with instrumentation. But now we understand them to be basically traces of the comet's orbit as it leaves debris behind within its orbit. So the dust tail is being blown off by the sun. Not quite opposite. It does change its angle a little bit. The ion tail is directly opposite the sun. And the anti-tail is basically the path of the comet's orbit that you're spotting. It's the dust that it's leaving behind in that path as it gets slowed down by the solar winds. So you can get these different features, these three different tails on comets. Now I have a couple other pictures here. This one was from back in, I think, just early winter of 2023, maybe January or February. We took this here as well, and you can see it's called Comet C2022 E3 ZTF. E3 in that case means third comet discovered in the fifth half month of the year. And this also includes Mars. So this comet got close enough to Mars that you could image it within the same field of view. That's also why it's a little bit wonky in terms of its shape, because when I took this image here, we have a live stream for this too, I think. I had to use the diagonals to my advantage. So I had to put one thing in on one side of my field of view and the other on the other side. And that I was able to capture both of them. Now notice with Comet ZTF, this was called the green comet, is how it was referred to in the news. And you can see that green color coming off of it. That's the green coma of gases around the comet being energized. Okay, so just to give you a variety of what you can experience with comets in our skies. You can see the dust tail on this one is much weaker compared to our current comet tonight, or Comet Hale-Bopp. And this video clip shows you, I believe this is ZTF as well, moving through the sky. This is another feature of comets that you'll notice, especially when they're in the inner solar system. They won't move like the star field moves. They wander like planets do because they're in orbit around our star. So if we watch it again, just one more time. Oh, one more click. You will see the comets moving separate from that star field in the background. So that's why this comet is climbing higher in the sky as the nights go on, why we have more time to observe it Tuesday compared to tonight. Tuesday night, I pretty much had to stop imaging at around 8 p.m. Then on Thursday night when we did our live stream, we were able to continue until 9 p.m. And tonight we should even have a bit longer. So it's climbing. And we'll see that in our stellarium demo. Now looking at comet sizes, where does our comet fall? We have quite a range here, from 1 mile to 85 miles. So Hale-Bopp was a big comet, and that's in part why it put on such a great show, 46 miles across. Our comet tonight is estimated to be about 2 miles. So much smaller, and that is often the case for these Oort cloud comets, as they will be smaller. Still, you don't want a 2-mile object colliding with Earth. So even though these comets on the Oort cloud are smaller, we're still worried about them, and why something like ATLAS monitors them. No, yeah, you wouldn't want a 1 mile either. So these are the scale of these objects, the comet nucleuses, again, the solid bodies where all the material's coming from. And one more time, I'll mention the Oort cloud. This Oort cloud is way, way out there in the far depths of the solar system. I believe the designator down there at the bottom is astronomical units. Yes, that should be right. And 1 AU, for reference, is the average distance from the Earth to the Sun throughout the year. So way out there, but still bounded, at least many of them, still bounded to our solar system. What is neat about comets is you really can have some that are interstellar. Sometimes they'll just drift in. Because all of these solar systems around us and throughout our galaxy have Oort clouds. You'll find that the way material is displaced around the solar system makes some sense. It's based on density. So rockier bodies like the Earth are in the inner solar system, whereas lighter materials are found on the outside, something like water and ice. And that's why we find all these comets collected along the Oort cloud. So this is where our 80,000 year period comet came from. All right. Now I'd like to just jump us into stellarium briefly to show you let's go stellarium web. What I like about stellarium web is that it populates major astronomical events for you. Oftentimes, unless there's a big update to Stellarium, the downloadable version of Stellarium, which you can get for Windows and Mac and everything, you often have to populate new data sets to bring comments and whatnot in. So this is handy just to go to the web version to see major events. Whoops. Don't run away on me. Just want to get you into Max. There we go. All right, so we need to look to the western sky, and you can see it. The comet's right there for you. This is free to use online as well, and it's free to download too. There's an app in the app stores as well. And as I look to the west and zoom in on our comet here, you can see this is current time, just after 8:30 p.m. And it's reporting right now a magnitude of almost 4, which, I would say is about right to what I saw earlier. And once we get to 5 and 6, that's where it really skirts that line of visibility. Your eyes will be hard-pressed to find that. And the altitude is about 10 degrees. So it is getting pretty low at this point, but like I said, it should hang on for the next 20, 30 minutes or so. And if we skip ahead through time, you can see how this comet moves. So first, actually, I'll go back in time to show you what it looked like on the 15th, since we've talked a fair bit about that observing date. So we'll go back a few days, keeping the time the same. You can see it at that point, already pretty well below our tree line especially. This is Stellarium's marking a true horizon. It's not accounting for the height of your trees or anything around your viewable area. But if we click forward, go back to today's date, it's also going to do an estimate of magnitude. So it's saying tomorrow night it'll be a 4, 4.27, it's actually not, based on the original estimates and what Stellarium's saying now, it might hang on for longer over the next few days at a lower brightness, but still visible to the eye. And here we are on the 26th, saying about 5.4. And here's where we reach 6 on October 30th. So it is going to continue to dim, but climb higher into the sky. What's also neat is it is going to start passing through the Milky Way, where there's a lot of neat objects, nebulae and star clusters there. So we might be able to get some cool images in that regard, because at a certain point, it just becomes an imaging comet. And you can also see if it ever ends up developing any sort of coma, like we saw with ZTF, some color changes, that can always potentially happen as well. All right, so we'll go back here. Definitely try Stellarium at home. And now what we're going to do is make comet soup. We're going to make a comet right here in the Space Science Lab. So what I'll do is I think I'll move this table out some. And I've got my recipe. And I've got my ingredients. All right. Oh, this one here is the most important ingredient. Oh, Drew. Drew, could you go into the utility closet and see if there's that plastic bowl? It's not in the kit. I didn't realize that. So while we get that, because it's going to be a little bit messy, and I don't want to get it all over the table. I'll show you the ingredients that make up a comet. Ooh, there's one. That's water. Just water, thankfully. So in this container, we have dry ice, carbon dioxide. That's a very high concentration found in a comet. The next one would be water. Lots of icy material. Again, coming from that Oort cloud. Now, you'll also find, we have a couple different types of this. In these cups, we have dirt. Well, sand, dirt, gravel, mixed variety, things like rocky materials, pebbles. You will find those embedded in the icy material as well. And then you have something like carbohydrates. And I have a couple of types of these too. Now, no, you're not going to find nerds in a comet. That's where nerds came from, didn't you know? So these are our carbohydrates as well. We'll add a little creative flair to our comet, some color. But it's complex materials like carbohydrates. And you'll find those in asteroids as well. And it's that leads to this theory that comets, asteroids colliding with a proto-Earth brought a lot of the material, the building blocks of life. Oh, the metal one will do. That'll work well.
For a big comet.
Yes. I'm sorry. Could you get a garbage bag too? Thank you.
Anything else while I'm out?
Sorry.
Sound familiar, guys?
So we also have iron. So you will find metallic iron in a comet. Iron is one of the more common metals. And we've got our nitrogen, which that's where you'd find like amino acids. Again, building blocks of life, early stages of protein development. You would find those in comets as well. And we have alcohols here too. We'll do a dash of that. And what's, yeah, I don't need that. Thank you. That's all I need. Appreciate it. So, to freeze and combine. Ooh, there we go. The sounds of a comet. So this is gravity in action. You need some pressure. All right, let's see. That'll work. All right, so here is our comet. And yeah, it looks like a dirty snowball. That's pretty much all it is, at least in its aesthetic. You saw that center porthole in our first slide, our title slide. That was a comet up close from the Rosetta spacecraft that got really up close and took images of the comet. And you can see, if you we'll take a look at that image again, it looked like a dirty snowball, effectively. So I'm going to come around a little bit and show you up close. I also need to model the solar wind. So I need to add heat and wind. Best way to do that is to breathe on it. So you can see a tail form. There's our dust tail. Okay, so we'll come around and show you up close. You can see as I move around the room too, kind of forms that tail. Okay. Come down the aisle. Now, I can't pass this around. Yeah, sure. We can go once more, modeling our comet tonight. That's all air my lungs had. Okay. Alrighty, so we'll leave that in there. What are we doing on time? Not a little bit longer. All right, so that concludes our comets discussion in part. Eventually, we're going to combine these two things. But now we're going to talk about meteors. And for this one, I will have something I can pass around. Let me get my started back up here. So I want to start off with this view of asteroid Bennu. So we're starting with this terminology, asteroid. And it's a big rock in space, as opposed to a big ice ball in space with our comets. This is asteroid Bennu with a picture from 2020 from the OSIRIS-REx spacecraft. And last year, OSIRIS-REx returned its sample from this rubble pile asteroid. Rubble pile is a fantastic name for it. As you can see, it's just this amalgam of rocks, pebbles, boulders. And that was important when they went looking for an asteroid to pull material from, because you can just scoop it. That's what OSIRIS-REx did. It was able to take it off the surface, store it, and then deliver it back to Earth. What's also cool is the entire OSIRIS-REx spacecraft didn't return. It was just a capsule. OSIRIS-REx is now called OSIRIS-APEX, and it's on its way to asteroid Apophis, which is one that at one time especially scientists were a little concerned over, because it was on a trajectory that it will bring it fairly close to Earth, to a point that it may be something that we can at least see as a little star-like object in our scopes. But that's for not until a few years yet. But that's what OSIRIS-APEX now is going to do. Is look at another asteroid that's going to be even nearer to Earth. So it's made of lots of pieces of rocky debris, all compressed together by gravity. Now, if you went down to OSIRIS-REx and you picked up a rock from its surface and threw it out into space, you could throw it out at a high enough velocity to get it at escape velocity, it would become a meteoroid. So meteoroids are little asteroids. They're little rocks, even down to pieces of sand and gravel. You could all call those meteoroids. Most likely similar in composition, but we're just talking about a sizing difference. Asteroid, meteoroid. Asteroids are big, meteoroids are small. So when it's flying through space, it's either called an asteroid or a meteoroid. When they fly through the atmosphere, it's at this point that they become meteors. So a meteor is a meteoroid, or even an asteroid, flying through our atmosphere. Again, preferably, let's just keep it to meteoroids flying through our atmosphere. And this is a shot of a Perseid meteor from August 12th of this year, flying through the aurora. So we saw the aurora on August 12th. We also saw it just last, it seems like forever ago, but just last Thursday, we saw the aurora again. This was a good display. The last one was an even bigger storm, the one just last week. So it was nice to have two opportunities there, and there may be more to come as well, as the sun is, I think they just suggested that we're in solar maximum right now. So But you can see the way it looks to a camera with a slightly longer exposure shot. This was a few seconds, I think about 3 seconds. You can see it looks like a streak across the sky. And that's not too far off from what your eyes will register a meteor flying through the sky as. Especially small ones, there'll be these quick little streaks across the sky.
Kind of like an artist.
Yeah. And that is what your eye would see. Now, as you scale up in what's entering our atmosphere, bigger meteoroids are going to result in a more dramatic display. And I should have one of those coming up. Ooh, it didn't register quite right. It was supposed to zoom in on that meteor, and it didn't want to do that. Oh, I know why. It'll do it on the next one. Do it properly on the next one. There we go. So here is August 12th again. And this is a Perseid meteor shooting through the aurora above our science center, just like before. But with this one, I want to zoom in a bit. And when I was putting this slide together, I realized, zooming in, I think there's a second one here too. Quite possible. It also could be I think this night was also a night where we were getting some weird space debris flying through our atmosphere, or in our upper atmosphere. It was interesting. We had some videos on Instagram and Facebook that you can check out of time lapses. It's all this material. That might be what we're seeing there. But this one is a meteor. And the tail end of it here is green in color. And it's not just green in color because of the aurora there. In this case, that color is coming from the composition of the meteor. So this one is telling us, because it's green, there's a fair bit of magnesium in it. And when that magnesium burns up in our atmosphere, it ionizes and shows up in that green color. Something like a sodium meteor would be more yellow in color. So depending on composition, you will get different colors in the sky. And the Perseid meteors in particular are famous for their magnesium or green meteors. And we can take a look at the colors in this video here of the 3 meteors that show up. There's one down here. And there'll be 2 more at the same time. This is at the peak of the Perseid meteor shower a couple years ago. Boom, boom. And what color? Green. So 2 magnesium meteors there. Iron can also be yellower or whiter in color. So that one down here was potentially more of just an iron meteorite. Or meteor. Okay. Now we can narrow in on the meteor shower that we're technically in right now. Meteor showers do have long ranges. So Perseid meteors you can see pretty much throughout all of August. The Orionid meteor shower starts in late September and continues through October. But there are peaks to these showers. And that's some of the information I'm going to provide to you with this one. But first, why do we have meteor showers at all? This is where we can connect everything. Comets and meteors. So Comet Halley leaves behind a trail as it orbits the sun once every 76 years. We talked about that comet earlier. And I think if this video plays, yep. You can see the orbit of this comet as it goes around the sun. A bigger comet and a much shorter period compared to tonight's. When it intersects Earth's orbit, when a comet's path intersects our orbit, that's what will lead to a meteor shower. Because this comet, as it goes around the sun, is leaving debris behind in that tail, and also that material spreads out through that orbit over time. You'll have different densities and pockets of material appear through that orbital path as well. So you can, year to year, we'll go through this orbital path every single year, every single October for the Orionids. And sometimes the showers will be better because you're entering a higher density zone of that material. Sometimes they'll be a little worse. There are other factors involved too, like what's out in the sky during the peak of a meteor shower, which we will see. Now, why are they called the Orionids? Well, this is the constellation Orion. And when we're thinking about the orbital path of this comet and its path through Earth's orbit, the trajectory of that path is aligned with a constellation in the sky. So we're literally running into a clump of comet dust. And that dust is aligned with a specific constellation. So we call meteor showers by the name of the constellation. In the case of the Perseids, the constellation's Perseus. In the case of the Orionids, it's Orionids. In the case of the Orionids, it's the constellation Orion. And this functions as the radiant point of the meteor shower. Now, does that mean that you should look directly at it at all times? No. Look where it's clearest in the sky, because meteors can appear during a meteor shower anywhere. It's just that they will trace back to the constellation in question. So you can always follow the tail of a meteor shooting through the sky back to its source. If it's different, if it's coming at a different angle, perpendicular or any other angle that's not pointing back to the source constellation, it's not an Orionid, or it wouldn't be a Perseid or whatever meteor shower is going on. That would be a random meteor, which can happen any night too. We see them pretty frequently here at Kopernik in our dark skies. You'll just see a random meteor shoot across the sky. Very exciting. But meteor showers are the best time to view them, gives you the greatest chance to spot meteors and potentially bright ones as well. So here is a picture of a bolide, or fireball, meteor. This is an example of a meteor that has, a very long visibility time. I don't mean minutes. It's still flying through space at many, many, many meters per second. And this, from this point to this point, is I think it was 5 or 6 seconds when I observed it, of full observing time. That's significant, because the little zippy ones that just appear as a dim streak through the sky, those ones are half a second, less than a second timeline. So this was significant. You can see it's filling up probably just over 50% of the sky, at least in one line across the sky from horizon to horizon. And this point right here is where I remember particles being thrown off of this meteor, indicating that it was actually falling apart as it flew through the atmosphere. So this is designated as a fireball. And it's where it's more than a streak. You're seeing material fly off. Like, I remember it being almost like sparks flying off the main body of the meteor. And it also had a very distinctive bright source, kind of like a comet. You get a very distinct nucleus, same with something like a fireball. So really good example of the best meteors that you can get before they start becoming a concern. And that would be more of a bolide or explosive asteroid, something that detonates in the sky. And those can be scary. There's big sonic booms that happen. You can look up numerous videos online of bolides, and they break windows, and it's a little crazy, but better than hitting the surface. All right. So this was at Cherry Springs State Park, by the way. Little plug here. Very nice skies there. If you have nearby, one of the nicest skies you can experience in our region of the states, with very limited light pollution. All right. So the peak of this meteor shower is October 20th through the 21st. So it's that evening, heading into the morning hours. Orion doesn't start rising until later on. So it is best to view a meteor shower when the constellation in question is above the horizon. So keep that in mind. You still see them early on in the evening, but if you can stay up to see the constellation rise, you'll have a better chance, because then you're not just getting what's above the constellation, you would be getting what's below it as well. All right, before we move on to that, I want to hop back into Stellarium and show you why, not to end the Orionid meteor shower talk on a major downer, I guess, but I want to show you why this year it won't be as good compared to another year. So let's jump back to current time. We'll go to the night of the 20th. And it's current time right now at 9 p.m. Orion's not up quite yet, but something is up. The moon. Just like tonight, nearly full moon. We are waning now, you can see it's a smaller moon on the 20th as well. Still a lot of light coming from that, and if we travel more through time, I got to turn my constellation lines on so you can see, and we'll leave the arc off. There's Orion. There's the moon. There's the constellation Orion. So Orion is this year not ideal. The Perseids were a good year because the moon was out of our way for the most part. That was nice too in the case of the aurora. But perhaps next year, let's see. Skip ahead a full year. Yeah, moon's gone. So 2025 is maybe the year for the Orionids. Not that you won't see any meteors, but it's going to limit your ability to see the very dim ones, which are the most frequent. You'll see a lot of those more often than the big bright ones. All right, so kind of to summarize everything here, I have this really nice graphic as poster from the American Meteor Society that takes you through, we'll hit play here as we scroll down it, all the different things that you would see in the sky, all the different rocky bodies, solid bodies out there in the solar system beyond planets and moons. So comets, you have asteroids, those small rocky iron or icy debris flying in space. Meteoroids is a small asteroid. You're talking little rocks even and pieces of gravel. Meteor showers, we talked about those a moment ago. Meteors flying through our atmosphere. A fireball is a meteor brighter than the planet Venus. And a bolide is light emitted by a large meteoroid or asteroid as it explodes in the atmosphere. And then a meteorite is a fragment of a meteoroid or asteroid that survives passage through the atmosphere and hits the ground. And this is what I have to pass around for you right now. As we start to wind things down, we're going to move to a Q&A section in just a moment too. But I want to show you and let you hold our meteorite sample. This fragment came from the very creatively named Meteor Crater in Arizona. And you can, we won't put the magnet on this one, but this is magnetic. I do have another sample we'll pass around that's a cross-section of a meteorite. And you can try the magnet on that one and see there's a lot of iron content here, a lot of nickel as well. And when you get it, please hold it with 2 hands because it's denser than you'd think. So we'll start passing it around over here. Okay. This is probably one of the oldest rocks you will ever hold. It's older than the Earth, at around 4.5 billion years old. Ooh. Slid right in. And where's my magnet? All right, the other sample is the cross section. We'll pass it around on, we'll start over here again. So this is a cross section of a meteor. You can see it has a little bit of a metallic sheen to it. And you can try the magnet as well. See, all that iron content makes it highly magnetic. Okay. And even one more. You also have tektites. And tektites are earth rock. They look a lot like meteors. You'll see they have these kind of cratered surfaces throughout. But don't let them fool you, because one, you'll feel they are much lighter than those rocks going around right now. And like I said, they're earth rock. They're melted earth rock, a type of igneous rock, not from something like a volcano, but from an impact of a meteor hitting the surface and melting rock around it due to the high energy involved with meteor impacts. So you can hold this one as well and kind of feel the difference with the tektite. All right, and one last shot I have for you is one that you said Robert took this, Drew? Yeah. Okay. Just through our 6-inch or through something else?
His C-star equivalent.
Oh, okay. Through its own personal scope. Okay. So yeah, Robert through his own scope just took this tonight of the comet, and what appears to be possibly a meteor shooting across the image. To your eye, it would be very dim, just based on the intensity we're seeing in the camera view. But this breakup right here is what would perhaps indicate meteor more likely than satellite. Satellites can take on this sort of path as well, but I'd say that break is a good indicator. I mean, we don't have the full path. If that break showed up multiple times along that path and it lasted in the sky for a while, it'd be probably a tumbling satellite that would be pulsing with a period. But still, kind of neat. It's very similar to what you'd see with a meteor streaking across the sky. So another image from tonight. And with that, are there any questions about comets or meteors or, yeah, anything?
We're going to do the Phil Donahue thing.
So when you showed the picture of the comet's orbit, and we're passing through the tail of it, or maybe it was so that's where the meteorites come from. How big is that trail?
The cloud can vary in size. I don't know offhand for Orionids how big the zones are, but that dust, those particles coming off of the comet, spread out quite a bit. So you could be talking thousands and thousands of miles as far as that spread goes. And like I said, it comes at different densities too of material, leading to better showers. If you've ever heard the term meteor storm, that's the next level up. Maybe you've experienced a meteor storm before. Meteor storms are when you enter major pockets of high density material and they just show up every moment. Meteor shower kind of leads you to believe that's what it would be like. Not quite. It's more like 20 meteors per hour for Orionids. Meteor storms are like a meteor every second. I got off on a tangent there, but yes, the path is something that you can look up, and they do try and estimate whether it be a good year or a bad year.
Do you have a question?
Where's this rock from?
Yeah, that rock, the meteorite samples are from Meteor Crater in Arizona. From that impact area, they found that fragment. Yeah.
Hold another question, Mick here.
Yes, I may have missed it, or how do those ice balls, the comets, form? And where did,
Yeah, so the comets in the Oort cloud and even something like Comet Halley that has a shorter period, they all formed in the early days of the solar system as well. Just like a lot of our asteroids, our planets, it's all part of planetary and solar system formation. And it's gravity pulling that material together. So kind of like what I mentioned earlier, that the solar system is spread out at different densities. So you have high density material at the center versus lower density material on the outside. It's like why you find gas giants out there. That's where all the lighter icy material went, a good amount of it, and it coalesced just like any other matter does in the universe and in solar systems. Yeah.
Does it get smaller as it travels?
It does, yes. The comet is losing material as it goes around the sun, and in some cases, it might not survive its path around the sun as it gets to its closest point. There's another comet that you may have seen in the news right now. I can't remember its name, but it's a sun grazer comet, meaning it's going to get hyper close to the sun. And most of the time, those sun grazer comets do not survive. There was even some worry that this one wasn't going to survive as well. But once it passed that point in late September, it survived, and after that point, they're confident. But this next one would be due for otherwise like early November, probably not going to make it, is what I've read so far.
All right, do we have any other questions here? Oh, we have one in the back, and
Yep.
so give me a second.
How can you tell a tektite from ordinary volcanic slag or something?
Ooh,
How do you differentiate?
That's a good question. I am not a geologist. I do not know my geology well.
I know one.
But yeah, at least going by what we're seeing between the two rocks and comparing those two, you can clearly notice a difference between the meteorite and the tektite. But in principle, it's still earth rock being melted and very similar to obsidian. We have some other samples, if it's not actually obsidian, some of those samples show that glassy surface. So I think probably the geology in the region would come into play. Like in Arizona, are there volcanoes? That impact was 40,000 years ago, and there was no volcanoes then either. So that'd be a good starter, is to understand the geology of the region, I'd assume.
I would also think just the smoothness, of that sample that you're picking up, that you wouldn't otherwise see that kind of smoothness, in just irregular geology. But did you have a question, or?
In 97, it was Hail Bop.
97 was Hale Bopp, yeah.
Okay, did you see that?
I didn't know, I was too young.
Okay, I did. I was coming back from inner space. That means I was kind of delirious, but I saw it, and it looked like it was moving. I saw it right in the middle of the city. It was that bright.
Oh, wow, that's amazing.
I know, and so can that appear, the tail can appear to make it look like it's moving?
Yeah, I don't know. I don't know for sure.
It did for me.
That's amazing, yeah. At least the comets I've seen so far, I've never seen any sort of apparent motion beyond moving through the star field. But if there's enough activity, maybe you'd see some motion over time.
There was a question from the chat. It says, what is the next comet to arrive? You sort of talked about that. I think also I'm wondering, is it space weather that they actually indicate where various asteroids, how close they're going to get to Earth? And my guess is they probably also will point out comets as well. So spaceweather.com is a great website. I go there all the time because if I want to see if there are any sunspots on the sun, you just go to spaceweather.com and they have a picture of immediately, of what's on the sun right now.
Yeah,
So-
yeah, that's a great resource out there to explore.
Another question here?
Not a question, but a little clarification on the question about how you tell the difference between the Earth rock and the space rock, the meteorite.
Yeah.
We had a gentleman doing a presentation last week at the Astrofest on the meteorites, and he had quite a collection of them. He pointed out that one of the differences is a primary way in which you can tell an Earth rock is different from a space rock or meteorite, is that the meteorite, as it comes through the atmosphere, gets extremely hot. And while it may be shaped similarly to what you would find as an Earth rock, the Earth rock will inevitably be smoother, and that as the space rock heats up coming through the atmosphere, it forms some sharp edges which then get very hot and melt and sort of mold into a ridge along that sharp edge. And if you find them like that, it's very clearly not an Earth rock, but vice versa, one that's as smooth as the one that the tektite. Then if it's that smooth, it's Earth rock, it's just automatically not a meteorite.
Oh, fascinating.
All right, unless there are any other questions, we have a rule here at Kopernik that, although I think most of you have checked that box off, is you can't leave here until you look through a telescope. So we will definitely have Saturn in one of our scopes. Jupiter will be coming up. The moon will be coming up, and we'll put some scopes on that as well, and we can do a bit of a star tour with lasers, and we're just so glad that you were able to come up here and enjoy this program tonight. Jenny, once again, fantastic program.
Thank you, everyone.
And again, normally every Friday night we do a public program. Next week is our special fundraiser, Hocus Focus. It's a sort of a haunting observatory. You're encouraged to come in costume. It's mostly aimed at the youth, but again, it's a family-friendly kind of an event. And you can go to our website. We actually limit the number of people that come in for those for that event, and we have two events on Friday and then 2 events on Saturday. And then the following week, we actually have a meteorologist from the National Weather Service that will be up talking about tornadoes. This year in New York State, we've had over 32 tornadoes. So they're going to talk about, how does the National Weather Service determine a tornado actually happened, but also talking about, normally we get like 8 to 9, maybe 10 tornadoes a year. We're blown way by that. I think the previous record was 25. So, again, not everything we do is talking about space, and so November 1st, I believe, is the tornado talk, and but you can always go to a website and you can hear about what's coming down the road. So, thank you for coming, and look forward to seeing you again soon, and look forward to seeing you outside in the scopes.
Thanks, everyone.